Comparing linear, exponential, and quadratic applications. So number one says, Jasmine bought a prepaid cell phone with a balance of $45. Each minute of talking costs 15 cents. Is this relationship linear, quadratic, or exponential? So if you start with $45 and you're just going down by 15 cents each time, that's linear. That's a linear rate. It's going to be linear. So it says, write an equation to represent the amount of money Jasmine has left, Y, on her prepaid phone after talking for X number of minutes. Use slope-intercept form. Okay, so I'm going to say Y, which is the money she has left. And then it's costing, so she starts with 45. So that's going to be our Y-intercept, our B. And then it cost her 15 cents per minute. So I'm going to go negative 0.15x. Remember, X stands for minute. So it's 15 cents per minute. And then with a positive 45 as my starting amount, my Y-intercept there. So that would be my equation. C says, use your equation to create a table and graph that represents the relationship between the balance remaining on the phone and minutes used. Okay, so the balance is $45 to start without using any minutes, right? If you plugged in 0, you would get 45. So now with this table, it looks like it's going by 50s. So let's just let's plug these in to the equation to get the balance. Okay, so 50 minutes used. So I'm just going to use my calculator and plug it into the equation for X. So I'm going to go 0.15 negative times 50 and then plus 45. I'm at $37.5. And then maybe I'll plug in 100. So 100 minutes, so 0.15 negative times 100 minutes, that'd be negative 15 plus 45 is 30. Let's plug in 150. So 150 minutes on the phone. So 150 times the 0.15 negative, and then add the 45, 22.5. And quite frankly, I don't have to keep on plugging these all in because it's linear, right? So, if I look at this, it's going down 7.5 each time, right? So I'm just going to continue the pattern here. That would be 15, be 7.5, and then 0. Okay, so we start off with $45. After 50 minutes, now it's at 37.5, so that would be here about. And then 100's at 30. 150, 22.5. 215. 250, 7.5. And then at 300, 0. Connect these. And there we have it. That's a linear relationship. So D asks, after how many minutes will the balance remaining reach 0? Now you could use the equation, substitute 0 in for Y and try to solve for X, but I mean, just look at the, right there. That's when it's going to be 0. Minutes used on phone, 300 minutes. That's when the balance is going to be 0. Actually, I didn't even need to look at the graph. I can see it on the table too. At 300 minutes, it's going to be 0. But like I was saying, if you wanted to, you could say 0 equals negative 0.15x plus the 45. Use the equation. Subtract 45 from each side. Divide by negative 0.15. And you would get you'd get 300 if you did it. That's another way. So there's plenty of ways to figure out when the balance would be 0. All right, next one. Tenter has brought a contagious virus to a town in Florida. Each day, those infected with the virus doubled. Is this linear, quadratic, exponential? So if we're doubling, that means we're multiplying by 2 each time. That's going to be exponential. Write an equation to represent the amount of people infected with the virus after X number of days. Use the form y equals a times b to the power of X. Okay. So I'm going to say y equals, so y is the number of people infected. A, remember, that's our starting amount. So we started with 10. There's 10 tourists times b to the power of X. So it's doubling. So we're going to go times 2 to the power of X. That would be my equation. C says create a table and graph to represent the relationship. Okay. So at 0 days, I mean, you could even just base it off the word problem. Remember, there was 10 people that brought it. So on day 0, total of 10 people. And then each day it doubles. So we could use the equation, or we could just double it. Double it. Double it. Double it. Double it. But again, we could have used the equation. For instance, if I wanted to figure out what the entry was for 5, I could go 2 to the 5th power and then times it by 10. I'd get 320. So you could use the equation too. So let's graph it. 0 is at 10. That'd be there. 1 is at 20. 2 is at 40. 3 is at 80. 4 is at 160. 5, 320. There we go. So this looks like a nice exponential curve. Oops. Okay. Now D says using your equation, find how many people will be infected after 9 days. So we could continue the table and keep on doubling, but let's use the let's do what it says and use the equation. So after 9 days, I'm going to go 10 times 2 to the 9th. 2 to the 9th. I'm going to do this all at one time in the calculator. 2 to the 9th. So 2yx 9. I got 512 times 10. So 5,120 be my solution there. Maybe I'll write people. Okay. Let me show you another. A small sandwich stand is considering different prices for their subs during their lunch hours to maximize profit. Below is the function a business analyst created to calculate their profit compared to the price X they set their subs to. Okay. Whew. So we have profit of X. So the idea is this, like, if you don't charge enough for your sandwich, like you make the price too little, you're not going to make much profit, right? It'll be low profit, or you might even lose money. Then the more you charge for it, the more profit you'll get. And then there's that sweet spot for a price. And then if you start charging too much, though, less people are going to buy it. You're going to have less and less profit. And yeah, so this is going to be a quadratic function. And you can tell because the equation is quadratic, right? It has an x to the second power. So this is going to be a quadratic function. So it says linear, quadratic, or exponential. This is quadratic because of that x squared term, right? All x squared functions are quadratic. Okay, B says create a table and graph to represent the relationship between the sandwich price and profit. Okay, so this is kind of a pain to make the table because we're going to have to plug in all of those sandwich prices in for X because X is the sandwich price. So yeah, all right. So let's plug in, let's substitute 3 in first, I guess. So here we go. If I were to do, there's not a lot of room to do this, so I'm just going to try to squeeze it in where I can. Okay, so I'm substituting 3 in there. 3 to the second power is 9. Negative 50 times 9 is negative 450. 600 times 3 is 1,800 minus the 1,350. So I got 450 negative plus 1800 minus 1350, 0. So I plug that in, I got 0. Okay, let me plug in 4 now. So I'm going to do P of, let me write this with 0. Okay, so P of 4, okay. Like I'm going to run out of room. So 4 to the second power is 16. So 50, negative 50 times 16, it's negative 800. Whoops, that's a plus. 600 times 4, that'd be 2,400. Okay, let me do that math. I got 250 there. Okay, let me do 5 now. Okay, 5 squared is 25. So negative 50 times 25 is negative 1,250. 600 times 5, that's 3,000. All right. I got 400 there. Keep on plugging along. Let me plug in 6 now. And I'm just kind of showing my work wherever I feel like it. Let's just do 6. So P of 6. Might be easier to show your work on a separate sheet of paper. Okay, 6 squared is 36. So negative 50 times 36, negative 1,800. 600 times 6 is 3,600. Okay. Okay. 450. Let's do 7 now. So we had negative 50 times 7 squared. What's the plus 600 times 7? Minus 1,350. 7 squared is 49. So 49 times negative 50 is negative 2,450. That's 4,200. I got 400. Now I got to substitute an 8, but listen, I think you've seen me do enough of these, okay? So you can do out the rest. I'm telling you, though, this is quadratic, and it's actually going to, the next one I'm just going to tell you is going to be 250, and the last one is going to be 0. It actually, if you look at it, goes 0, 250, 400, 450, and then it drops back down to 400, 250, 0, okay? I'm just, I'm not going to write out the rest of the work there. So let me plot it. So at 3, it's at 0. At 4, it's at 250. At 5, it's at 400. At 6, it's at 450. At 8, it's at, wait, no, I forgot to do something. 7 is 400. At 8, it's 250. And at 9, it's 0. So there we go. Got a nice parabola. So A says, for what sandwich price should the sandwich shop set in order to maximize their profit? Well, for what sandwich price maximizes the profit? Well, the maximum profit is here, right? This would be at 6, 450. So the sandwich price is 6. At $6, they're going to maximize their profit. Now the profit will be 450, but the sandwich price we want at 6. Okay. For what sandwich prices would the sandwich shop make a profit of $0? That would be, you can see it in a couple places, at $3 and at $9. And you can even see it in the table at $3 and $9. So I'm going to say $3 and $9. Okay, so I'm going to let you do the rest. Hopefully that helps.